Hello and a warm welcome back. Today on the bench is the 2C34 push-pull AB class AB2 amplifier. As you can see, I'm a little bit further forward, but to get to this point we need to go back in time. Well, I've finished drilling holes, I think, or most of the holes for this top plate, and so now it's a matter of getting it prepped ready for painting. So the first thing to do is to pull the plastic off. I'm just about ready to do some painting. The two bits of metal that I need to paint are just about prepped. Well, this one is prepped. So we've got the power in, IEC power with it's got a combined fuse. I won't get it out. Two speaker terminals, RCA's in. And what I'm going to do, I'm going to try a trick that I learnt off this channel, Neville somebody or other his name is, and he basically is covering the restoration of the Lancaster plane at East Kirby, just up the road here. And what they were saying, because they deal with a lot of aluminium, the Lancaster is mostly made out of alley sheet riveted together, and they have to paint it and inspect it and all that, is that they mentioned using some sort of acid to etch the aluminium prior to painting. And I sort of looked into it a little bit, not in great detail, and I think basically the idea is that the acid etches, puts little tiny holes all over the metal, and yeah, we get better adhesion of the paint. Paint sticks better. The other thing I've done, I've knocked over all the corners. We've got this here, this stock. I can't remember where I found it. Some skip somewhere a long time ago, and it's really weird, Ali. It's really hard to drill this out. Was a right pig. I had to like sharpen drills and everything. It's like, I don't know, it's more like stainless. Anyway, so we'll have a go with that. I've got a few more holes to drill on this one. I've already knocked all the edges off, because the problem when you paint aluminium, I've found, or any metal really, if you've got a sharp 90-degree edge, then obviously the paint doesn't want to stick to the edge. So if you just sort of chamfer it a little bit, then that just rounds it off, and hopefully the paint should stick better and not chip off at the edges. So I'm going to put some acid on here. This is just normal citric acid you get, for cooking and all that. Just a bit of water in it. I'm just going to try bunging a bit of that on. As you can see, it's sort of reacting with it. And I shall let you know how I get on, if it sticks any better. Well, I just made a big boo-boo trying to make another bracket like that one, but I've well, I know what I've done. I've made the holes probably, well, let's have a look at the job. The bending's about right, but me hole placement is wrong. So as a result, yeah, it's an hour wasted, totally bollocks. Yes, what's over this thing? HT power supply for the new amplifier. As you can see, I've just got it all sort of cobbled together. Nothing's gone bang. We have two 820 microfarad capacitors forming a CLC filter, and at the moment on the tapping that we've got on the transformer we have 325 volts. The mains voltage is probably a bit high. I've got it on the isolation transformer and variac. I also had the lamp limiter. I also have the lamp limiter on. I'm just going to knock that off. As you can see, the DC voltage has gone up, and now I'm going to connect a load. This is a 5k load. And that's dropped by 20 volts. I've also got a scope probe on there. If I point you at the scope, you will see nothing. Sort of ducking about a bit. Not quite sure why that is. It's probably I think the cap in this plug-in is getting a bit tired, so it's leaky, so you see the trace going up and down. So that's with the 5k load. That is simulating a sort of quiescent current situation with all the output valves basically just sitting at quiescent. We can try changing the load to see if by putting more of a load on there we get any ripple, but I can't see any ripple at all there. If I just flick me meter onto AC, I am getting 10 to 20 millivolts of ripple, which is okay. Right, let's try putting a bigger load on that. And that's stimulating a load of about 150 milliamps. Probably more like 200 milliamps. And as you saw, there was no ripple. Conclusions: the transformer is up to providing all the current, which is what I designed it for. Designed it to be really stiff. The 820 microfarad capacitors aren't too big for the transformer. If they were too big for the transformer, we'd be seeing loads of ripple on there even without a load. And we know that the power supply is really stiff and can supply the current whatever load in. So in class AB2 there's a reasonably heavy load, but it will be nothing like what we've just simulated there by using a big resistor. So that's good. I've primed the two bits of metal that needed painting, the top bit and the back panel, with etching primer. I think that acid etch that I put on it did do something. It seems to have adhered quite well. I need to let that dry now because I put those final two coats on this morning. Let it dry for 24 hours. Tomorrow I shall give it a rub down with some wet and dry sandpaper. Next I'm going to make the little bias supply, which is just a matter of fettling like a bit of copper clad board. Just working on the bias supply. So we've got a bridge rectifier. I should have done this like a Blue Peter. Should have done that before, and anyway, you get the gist. That goes in here. Two big caps. That's all it is. Bridge rectifier and a CRC filter. They go in like that. The resistor will go underneath, and that will give us a nice sturdy supply to provide not only the bias supply for the output caps, but also the constant current source well, no, the constant current sinks, properly speaking. Right, I shall crack on with that. Just use my drill to carve out the various traces. Job done. I've also got the first coat of black paint on the metalwork. It's not looking too bad. There's a few bits of hairs and motes of dust in there, but in this house it's nigh impossible not to get little bits of dust and whatnot in there. So what I did this morning, after applying 3 coats of etching primer, was give it a rub down with some 400 grit wet and dry, then 1000 grit wet and dry. Cleaned it all off with water, just tap water that is, and let it dry out, and away we go. Wobble cam. I painted this bit of I painted this panel this morning, went out for lunch with my daughter, and while I was out, the paper over there obviously blew on there and stuck to it, which is most disconcerting. So I'm hoping that I'll be able to get it off with a bit of water and wet and dry, but if not, got to start all over again. The trials and tribulations of an amplifier builder, eh? Oh well, see you in a bit. I've managed to get the paper off, but obviously there's a consequence. The paper is off, but I've abraded, sanded through the black paint into the primer, although I haven't gone into the metal. Yeah, it doesn't look good. A bit of a mess. So what I'm going to do, I have some used 2000 grit paper, wet and dry, and I'm going to give it a very gentle sort of going over with that, and then have another, put another coat in the morning. Here we are, quite a few days later. You can see the top panel is painted. It isn't perfect, but I'm going to get it perfect. I've been here before with motorbike tanks, spending weeks and weeks trying to get them perfect. Yeah. And the other thing is, when I punched these holes out, I did these 3. If you can see, there's like a bit of sort of dinking. The chassis punch has 2 bits. It has this big round sort of dish, and then it has this cutter. And so what I did it from this side the first time, and from the other side the second time. That makes a better, cleaner hole from the front. So I screwed up there. I am not going to make another one of these. This took long enough. And there's a few bits of paint screw ups, one there where it dripped a bit, and then where that paper went the other day, I rubbed that paper off, but you can see a mark there. It'll have to do. Like I say, I'm not spending weeks on it. The back turned out better, no real sort of blemishes or anything. That turned out okay. However, one thing I did notice, the paint, this stuff, how's beard. I mean, I sort of wore a sort of simple mask and everything. This made me feel really freaking ill, and I have noticed this. So there's a local shop which sort of sells discount stuff. This is the paint, this is the stuff that they used to stock in the old days. This doesn't smell too bad. I mean, it still stinks, but this is like literally you just one sort of whiff of it and you want to get out of there because it's horrible. And so all I can think is that since Brexit and COVID and all that, manufacturers of paint have started like putting different cheaper ingredients in. And so I read the, where do you call it, the contains the ingredients sort of thing. All this one says is that it contains acetone, the black one. This one has a great long list of acetone, N-butyl acetate, 2-methoxy-1-methyl ethyl acetate, butan 1-OL. One of those, I'm going to look into them. Yeah, must be absolutely horrible. And I've also noticed it in supermarket packaging. The glue that they used to have, say, on a pizza box, you could just like run your thumb along it and it'll come away. Now the glue is different, and I've noticed they started using cardboard in a lot of packaging instead of plastic. Anyway, this is where we are, and this is not about amplifiers. I digress as usual. So having got all that sort of pretty much drilled and painted and all the rest of it, I just need to put it together. There is still a few holes I need to drill, which I forgot to drill beforehand, but it should be I should be able to do that without making a cock up. However, problem with paint is, even though you can let it sort of dry overnight, it's still very easy to dink it. And so I have these lovely old chrome handles. I shall fit those on there so that when I'm working on it, that'll keep the paint away from, you know, the worktop and things like that. Yeah, these came off an old bit of test gear. Really nice chunky brass, chrome plated brass. So I shall get that done. Let me show you the boxy thing. The wooden box, again, we've got imperfections. As you can see, we've got a big crack there. I actually glued that up. But when I was cutting this prior to like planing and everything, I didn't want to saw against the grain, so I just used a big bill hook to like sort of fettle it down, you know, like an axe. And unfortunately I slipped, and it, with the grain not being straight, yeah, anyway, it is what it is. So that's the lighting, and somewhere we've got the power switch. The power switch took me a long time to try and settle on something that would work. If I was to use something like that, which would have been my preference, then we've got this problem whereby it isn't long enough without like carving bits out for the thread and all that. I didn't want to do that, so I went for a push type. I just can't see, and then found that I didn't have a suitable knob. So what I did, I got a old brass standoff, cut it down, filed it inside square ish, and then I used a bit of mahogany or some sort of old wood, chopped a bit off this mahogany here, rounded it off, popped it in. Job's a good one. And that, and find the blinking hole, will fit there. Not 100% happy with it, but you know, you can spend like hours and days just prevaricating and trying to make it 100%. Well, quite a few hours later, seem to have taken an inordinately amount of time. The back panel is populated with the speaker banana jacks, left in, right in, IEC in. Yes, I know, it's a bit cocked up there. Should have moved everything over that way a tad, but that's okay. That's not going to affect the speaker out, so that's ground. Purposely did that at the time. That's cushy, and you bugger, you always squeak. And that don't look too bad, does it? When that's got some valves in there and the output transformers on, it'll look quite swish, I think. She'll get all the valve bases on and what have you, and then I really am looking forward to start wiring it up and then getting some sine waves out. That'd be great, because it takes a hell of a long time to get here. How long does it took? Feels like months. Probably is a couple of months, but you know, that's DIY valve amplifier building, unless you can buy all the bits and everything. So this way saves money, just takes longer. Right, I shall crack on. There's all the valve bases in and the terminal board for the heater wiring. So the next thing to do is to wire all the heaters in. I've also wired the mains into the amplifier, so on the back there, so as you can see we've got our IEC in, fuse holder, speaker left, speaker right, sorry, speaker left, in left and right, twisted correctly coded wires, retained there. Ooh, that's not straight. That's gonna give me freaking nightmares, that is. Oh, that's not straight. Damnation. I'll just have to move it up a little bit. All these things bug me. That goes into this main switch, double pole, single throat. There we go, lovely. That will then come over there into here, thusly, something like that, into our transformer. All the audio is down there, so this mains wiring, I mean, yes, it's twisted and everything, is out the way. I've also bit of belt and braces, as well as the big alley screen thing. I put a bit of copper around there, and this is a shield rather than a screen. There are two different types of screen shields. So what I shall do is just solder on another wire, connect it to the other screen, which is in between the primary and the secondary, and that should doubly make sure that there is no high, so the screen inside basically stops any high frequency, let me just make sure that's off, any high frequency harmonics or whatever, or all that shit going from your mains input voltage into your secondary voltages. And then the shield, that makes sure that there is no stray magnetic, or it reduces straight magnetic fields coming off here on this direction, potentially interfering with our high impedance, high gain audio signals. Hope that makes sense. Sorry, I'm never quite with it, but yeah, it's been a difficult few weeks. I feel shit again. Anyway, let's crack on. There's a few other bits and bobs actually before I go sailing away into the sunset like fickle Bobby. There is another test we can do, which I shall endeavour to show you now. So what we've got here is called the Quasimodo. If you go on DIY audio, Mark Johnson designed and all the rest of it, this bit of kit. Basically what it does via this big MOSFET here, it just sends a pulse into the secondary of the transformer, in this case the mains transformer. Don't know if you can use it for output transformers. And it's a way of finding the snubber that you need across the secondary of a transformer, so that it damps any resonant frequencies. This is not a how-to video, so I won't go into all the ins and outs, but basically between the primary and the secondaries, in this case, we have leakage inductance, and then there's capacitance, stray capacitance, and all the rest of it. Right, let me point you at the scope. As you can see there, what the test rig is doing is sending a pulse, bump, 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 every, I don't know, however many seconds it is. What we need to do is damp those pulses. So if I swing you back to the test rig, we have a 10-turn precision pot here. I'm going to adjust that, and then we have a couple of capacitors here. This is a 150, where are we, 154, so that's 150 nanofarad and a 10 nanofarad cap. Like I say, you'll have to look at the article and get your head around it yourselves. So what I'm going to do is adjust that pot, and then we'll look at the screen, and we should see those pulses either growing or reducing. That seems to be the best we can do there. So it basically is to design an RC snubber without doing all the maths. So I think what I need to do is to try a different capacitor. I'm going to do that off camera to try and keep this video short, because this is about building a valve amplifier, not about snubbers. To make finding capacitor X easier, I broke out my capacitance decade box, and so what I'm doing, I'm just trying to dial it in so that any resonance that we get is damped out. So if I point you at the scope screen, right, so there we've got like the resonance bump, and I should tell you what I've got at the moment. At the moment I've got 200 nanofarads, about 201. So let's try dialing up the sort of 10N. Right, so now that is at 27, right, 270 nanofarads. Right. 200 nanofarads. So let's see what happens if I bung in 1 microfarad. As you can see, well, you can't see, that seems to make that worse. If I play with the resistive part, adjust the resistor, see that just jiggles that about, don't really make any difference. Alright, so let's try adding even more capacitance, and as you can see, that just makes things worse. So let's dial back the capacitance. So now we've got 200 nanofarads. Let me just jiggle you back. Where are we? 100 nanofarads. And as you can see, no capacitance at all. So that's 100, 200, 300, and then you sort of reach a sort of point and it starts getting worse. So where are we? That's 400, that's 300. Let's try it in a few, like go for something like 330N. That's 330. So let's try that, because that's a common, where do you call it, value. And that just seems to shift that up and down. This is the resistor I'm mucking about with, so that's P key. So I would say somewhere like that. I think that's as good as we're going to get it, to be frank. And so now I've got to basically measure the resistive part we know what the capacitance part is and all the rest of it. Before I finish off on this section, you don't have to do all this, but it just makes a quiet sort of power supply, and I haven't used the Quasimodo test rig for quite a while, so I thought I'd break it out and just show it to you, and you know, it makes an interesting sort of side of it, apart from me filing and all the rest of it. Right, let's crack on with a build. And here we are, back to the future once again. Thank you very much all of you for watching. Hope you got something out of that. Take care of yourselves. Ta-ra for now.